Welcome to Easy Maths. In this lesson, we're going to focus attention on the concept of chords again as we continue with our series of lessons on the topic of circles, chords, and tangents. And so we turn now to the day's lesson. Chords intersecting externally. We have two chords KL and NM which intersect at X, and therefore we say KX is a secant, same way as NX. Now we have a chord KM which we can include there, and also NL, and with those two we can actually say that MKX, the angle MKX is the same as the angle LNX, because they are subtended the same chord LM on the same segment. You see, we have the chord LM subtending the angle K, and yet the same chord LM subtends the angle N. Therefore, they should be equal. We label them A, and we have the angle KMN and NLK, which also are equal because they are subtended by the same chord KN. The chord KN subtends the angles, that one at L, and subtends also the angle M again there, and they should be equal. We label them B, and that means the remaining part of that straight line KX and NX, the remaining part there, this angle here, we can label it D, both of those. Now please notice that KXM and NXL should be equal because they're common angle, and the reason is we have a triangle KMX, that is KMX there, with the angles A, D, and C, the one I've just talked about there. And we have another triangle NLX with the angles A, D, and C again. So I was saying that C is common. No wonder it appears like that way, because the two triangles kind of intersect in that particular point at X. Now, if that is true, we can say that the triangle KXM is similar or congruent to the triangle NXL. So you see KXM and NXL. And look at them here. KXM and the triangle NXL. They are congruent. If they are, as we've done in a previous case, we can write KX divided by NX. KX divided by NX is the same as XM divided by XL. Please notice the order of KX, NX, and XL and XM in the way they appear here. Now again, if this is true, we can cross multiply and get the expression or the equation KM XL is equals to NX times XM. And this is true for two chords intersecting externally, as I have tried to indicate there, or to show you from there. Now that means that whenever we're given 3 dimensions of the 4 dimensions in two chords which are intersecting externally, we can get the fourth one using this equation. And so maybe we should turn to an example. We're given a question there where we're told that AB is 5, BQ is 6, DQ is 4. We look for the distance CD. What do? We write the equation AQ times QB is same as CQ times QD. That is AQ times QB is same as CQ times D times QD. And we know that these distances, we have only 3 dimensions or 3 distances, and we can get the fourth one using the formula that we've just generated in the previous few minutes in the example that I had. With this one, therefore, we're going to write 11 times 6, because 11 is the length AQ, times 6, which is the length QB, is same as CD plus 4, the whole of this distance, times 4. And with that, we get 66 equals 4 CD plus 16, and therefore CD must be 12.5. And that brings me to the end of that lesson on circles, on chords that are intersecting externally, or in the case where we have a secant. Check out for the next video, which will be to do with the tangents, as we progress in our lessons on the topic of circles, chords, and tangents. And as always, please like, share, subscribe. I'll appreciate it. Thank you.